Hola, SAP developers. Welcome to this session, part of the Oktoberfest 2023 integration track. Before we start, I just want to let you know to please feel free to drop us your questions on the chat window, as we will be monitoring it and we will answer your questions then. I want to welcome today Simon, Arne, and Farouk, who are part of AWS, and they will be sharing with us details on how we can leverage SAP Private Link with AWS and secure the connection between our SAP BTP services and AWS. Without any further delay, hola, Simon, Arne, and Farouk, over to you guys.
Thank you. Hello, everybody. Well, thanks for joining this presentation today. We'll be talking about connectivity between SAP BTP and Amazon Web Services. My name is Simon Purcell, and I'm a Senior Solution Architect with AWS. In this presentation, we'll look at business challenges around the connectivity between cloud services and the solutions to address these challenges. Let's get started. So what we'll be looking at today, we will look at some of the main business challenges and then the use cases that we provide to address these challenges. We'll look at AWS Private Link service, and then obviously the SAP Private Link service that sits on top of AWS Private Link. We'll look at some connectivity use cases for S/4HANA, some native AWS services, and also some cross-region replication. And finally, I'll hand over to my colleague Farouk to perform a demo of a solution utilizing SAP Private Link. Security is top of mind for CIOs and CISOs, and they're driving a zero trust initiatives across the entire organization. Zero trust initiatives have three key pillars: users, workloads, and network. And today we're going to focus on workload and network aspects. Customers need private connectivity between their virtual private clouds. They don't trust the third-party application traffic and would like to have a better visibility. Customers in financial services, healthcare, and government sectors need to adhere to regulatory measures and achieve compliance. Preventing your sensitive data, such as customer records, from traversing the internet helps you maintain compliance with regulations such as HIPAA, EU and US Privacy Shield, and PCI. Customers don't want to run their cloud workload traffic over the public internet. They don't want their network, resources, and services to be reachable over the internet, as this is one of the biggest threats. And finally, they must be cost effective. Now let's talk about AWS Private Link use cases that will help us address these business challenges. There are four key use cases. Secure restricted access to AWS services which are outside of your private network. These services could be AWS services, such as databases, messaging, and Lambda. Secure restricted access to customers' own homegrown internal applications, or third-party SaaS applications, such as Datadog, Snowflake, Terraform, which are outside your private network. You could also build your internal services and share them with your organization. For instance, one of our largest customers, for example, has over 3,000 internal services shared over Private Link. And the fourth case is enable hybrid cloud, a resource in your data center that needs to access certain workloads in the cloud over a direct connection or a VPN using Private Link. Or you could have legacy applications in the on-prem data center. And you could use Private Link to make it accessible from AWS Cloud for your organization. Let's review what AWS Private Link is and what it does. Private Link combines two cloud constructs. A VPC, which is a private network that can be isolated from the internet and other VPCs. A traditional SaaS operated by third parties, which are generally required internet access, but now you are making accessible in your private network. AWS Private Link makes third-party SaaS services an extension of your private network, and it does it securely by restricting the access. Private Link allows applications in your VPC to access a service from another VPC. AWS services, SaaS applications, and data as a service solutions will be presented as an IP address in your VPC, even though they may be hosted in another VPC or even another AWS account. Traffic is routed through the AWS private network and does not travel over the internet, and there are no public IP addresses involved. Users can send requests and receive responses from other services over a Private Link connection, but services cannot access other resources in that user's VPC. And only a consumer can initiate the Private Link connection. Linking back to the Zero Trust framework, no third-party SaaS can automatically reach you into your private cloud. All private link connections must be mutually initiated to maintain a secure posture. So what is AWS Private Link service? A service provider creates an endpoint service to make their service available in a region. A service provider must specify a load balancer when creating an endpoint service. The load balancer receives requests from a service consumer and then routes them to this service. By default, your endpoint service is not available to service consumers. You must add permissions that allow specific AWS principals to connect to your endpoint service. The service consumer creates a VPC endpoint for the service, specifying the service name from the provider. The endpoint network interfaces are created for every subnet specified in your VPC endpoint creation. AWS Private Link provides private connectivity between VPCs, AWS services, and your on-premise network without exposing the traffic to the public internet. Private Link makes it easy to connect services across different accounts and VPCs to significantly simplify your network architecture. The interface endpoints are created directly inside of your VPC using the ENIs, Elastic Network Interfaces, and IP addresses from your VPC subnet. You can associate security groups and attach endpoint policies to the interface endpoints of an AWS service to control access to specified service. The diagram here shows a VPC on the left, which has several EC2 instances in a private subnet with 3 interface VPC endpoints. The topmost VPC endpoint connects to an AWS service, like Lambda or RDS. The middle VPC endpoint connects to a service hosted by another AWS account. And the bottom VPC endpoint connects to an AWS Marketplace partner service. What is SAP Private Link? SAP Private Link is a service that establishes a direct connection between your BTP account and your AWS account. It leverages the AWS Private Link service, as we just described in the previous slides. Data is transferred over the private network, avoiding exposure to public internet. Although it's important to highlight that if you establish a connection between a BTP account hosted in AWS and your AWS account, there is a high likelihood of the traffic going through internal network. The difference with Private Link is that it guarantees the traffic will go through the private network. It enables customers to access services in their AWS provider accounts from SAP BTP through private network connection. In the future, the service plans to also support additional scenarios for customers and partners that want to access selected SAP BTP services via a private network connection from within their own hyperscaler accounts. Let's just quickly run through some possible scenarios on AWS. Here we can see a number of supported scenarios and scenarios which are on the roadmap. First, we start with consuming an AWS service from an AWS customer account within BTP. And then we can see consumption of an S4 service in the customer account by SAP BTP. Thirdly, we can see a third-party service in the customer's AWS account. And finally, we see the consumption of an S4 service via Cloud Connector, which is on the future roadmap. The second scenario, which is on the roadmap, is the consumption of SAP BTP services from within the AWS customer account. And finally, the third scenario, which again is on the roadmap, is consumption of a BTP service from another BTP account. Beside these supported AWS services, you can consume your own services with SAP Private Link. You can create an endpoint service for your S4 HANA system running on an EC2 instance. This allows private communication between BTP applications and your SAP system. It's now easy for developers of Cloud Foundry applications to consume, for example, OData services of an S4 system, while the S4 system is not exposed to the internet. Applications developed and running on BTP Cloud Foundry runtime can now leverage AWS services to enrich the functionality and consume services directly on AWS. For example, you can store data in your BTP application on Amazon S3 or send emails via Amazon SES. The communication is initiated from BTP side, and the entire communication stays private. Traffic destined for the AWS service is resolved to a private IP address of the endpoint network interface, and then sent to the AWS service using the connection between the VPC endpoint and the AWS service. For AWS endpoint services across AWS regions, you can create a VPC in the same AWS region as your BTP Cloud Foundry runtime, and then connect these VPCs via VPC peering or AWS Transit Gateway. This is helpful if you want to run your S/4HANA system in a separate region and your BTP account in another region. And finally, I'd like now to hand over to my colleague Farouk, who's going to perform a demo for you of a SAP connection using Private Link to AWS services. Thank you.
So thank you, Simon. First of all, I'll introduce myself. So my name is Farooq Mustafa. I'm a solutions architect here at AWS, and I work on providing certain solutions to AI and SAP. So today I will be showing you a demo of how you can utilize a private link and build an app and communicate with AWS GenAI services. So let's start with it. So I'm showing you an architecture right now where we have built a private link, and we're gonna build an app that is going to talk to AWS GenAI services using a Lambda function. So let's start from what are we trying to do. So in this scenario, if you see on your screen, we have built an app that actually takes data from Northwind using a destination service, and this data is being pushed to a Lambda function, and the Lambda function using a SageMaker LLM, a large language model, will answer user queries. So we'll start the flow here. Let's say a user asks the bot, what is the address, or what is the phone number, or what is the where does this person work in your company's index. It will take that query, it will go into UI front app. The front end will talk to the CAP backend, and in the backend we have the first step is to get the authentication. We're using IAM roles anywhere, which I'll show you in a little bit. Once we have the STS token, we talk to Lambda function using a private link. The private link calls a destination service in Cloud Foundry, and that there is a destination called Northwind in it, and gets the JSON, loads it back into Lambda. Lambda then gives all that information to the SageMaker LLM. In case you have an advanced use case where you have a lot of data, so there is the live data that's coming from Northwind that is changing pretty quickly, like the location of an asset that can come using number 8. But let's say you have like an old purchase order or old sales order or any other information that's now not going to change. You can load that using Amazon Kendra, which is an indexing server, or it can also crawl a web, and it has a lot of connectors. You can use all of that to load old data, and now the Lambda orchestrator will take the live context, the data that's changing from number 8, the data that is in Kendra using indexing and Elasticsearch, and give it to the LLM. With all that context, now LLM will answer pretty what you call accurately, I mean mostly accurately, to the user. You can actually add SAP S4 on AWS, or you can actually connect with Rise with SAP. All those options, Lambda is the heart of it. If you are not going to use a Lambda, you can use an EC2 instance, however you want to do it. But the goal is to show you how it actually sits in all these places. So this is one. After this, let me get to the code quickly, and then I'll show you the demo. So let's go on to the next screen. So this, I'll start with the CAP backend. So we are here. So the front end, as you know, I have only two places, the user input and the bot response. And the CAP backend is which takes that response and process it. If you see, I have two CAP backend. Let me explain this. So in my case, I'm asking Lambda to call this just to show that this is a possibility. You can actually go out and come back in using OAuth. In my case, I'm doing OAuth. You can try any other authentication. But let's say you want to make it even quicker. You can actually call inside a destination service, get the data first, and then give it to Lambda. So these are possibilities. Any other way you want to do. So let me go to the code now. So we're loading AWS SDK. I'll start with this section. This is important. So I have built a private link Lambda as a service, and I'm trying to get its host name. So first thing is I get the whole thing from my private link using the, this is the function I built that actually gets the environmental variables from the service. I'm taking the host out of it, and then I'm building an endpoint, just the name, HTTPS, and then the name. Region is US West 2 if you want to, or US East 1. We're building a shell Lambda endpoint using this one. Once I have that, now I'm gonna give it the parameters region, endpoint. This is the IAM roles anywhere config. So mostly you have seen user ID, password, or STS or short-term tokens on how you're gonna access AWS. This is a new way called IAM roles anywhere, where you can actually have a certificate that you got from AWS, and using that certificate, you do all the communication. So it's pretty cool. Try it out. So in this case, we have a profile. We have 2 text files. I'm not gonna go into detail. You can check it online, but these are just text file. One of them actually tells what to run. There is a helper file with the context and certificate and all other details. Once you have a Lambda client, we have what are we going to send to the Lambda? So this is very important. So it's looking for a body. It's looking for a question represented here by Q. A max length. Top K is the token with the highest probabilities. And these are all LLM parameters. You have P, which is the sampling, nucleus sampling, they call it, or smallest group of tokens grouped from K. We can read about it. Temperature means how accurate you want the information to be. All that comes in the payload, and the function name you're calling, all that comes here. And then we're just doing a send command to send it. And when the data comes back, we just JSON parse it. That's it. So this is the CAP backend. So now we're going to go to Lambda. So the same payload as you see here, now we're giving it as in the form of an event to a Lambda handler. So Lambda handler always have this event and a context. Event is what comes from their context is the runtime environment for Lambda, like the Lambda's name, configuration, its memory, and all that is in the context. So we took the body portion out of it, and we're calling a function called RAG handler, which is the retrieval augmented generation, with one of the ways where you have a already built a large language model and you want to have a context with it. One of the ways is RAG handler. We're bringing the context from SAP. So read the provided data from SAP shown in JSON format. So I'm giving I'm telling LLM that go read the data from this call here. And once you have that, answer the question. So I built a variable called question with context. Whatever we got from SAP, we built a whole, it starts with this line, then it has a JSON, and then it has a question at the end. So just build, create full prompt. The prompt is going to be in this format. We have a prompt template which use this, all this, and build a template. Finally, I would like to use load QA chain. This is a function of LangChain, and you can use load QA chain. There are other functions available where you can call LangChain and do all this. If you have documents loaded in Kendra, you can do Kendra retriever. It's as I said, it's an indexing server. It's gonna query all the documents and then find out which one has the closest to what your question is. It will give all that information, docs, question with context, to the LLM, and the output. When we get the output, we give it back to SAP. So this is the SAP. I'll show you one snippet of call SAP destination. How did I do it? It's pretty common. I get the SAP authentication token, went to OAuth token, get the token from SAP. Once I have that, I mean, this is just a function, I called it here. So once I have the token, I called my URL. This is not a full URL, but I called my application Northwind. That is, I built an application called Northwind that is actually just a wrapper application calling Northwind using destination service. And I'm giving it a path and I'm getting the response, and that's it. So this response goes back to the Lambda, and the Lambda processes it. So that's the end of code. Now I'm going to show you how all this shows up in a, do you see my, so I have to shift now, right?
Yeah, this is fine. We can see your screen.
Oh, you can see, okay. All right, so I'll start here. So first thing, let's start with how do you get to a private link? How do you add it? So the first thing is you go to entitlements, you add a service plan, and I've already written private link. So if you have a private link, you bring it up. In my case, I've already added it, but you can add it here. This is how you're going to add it to a sub account. Once you have a private link, the next step is to create one. So once you press the create button on this corner, you choose private link service. Standard, I understand you should read the disclaimer and all that. Give it a name, private link Lambda 2. In the next step, it will ask you for the service name. So I'm copying one. Hold on one second. So here you want desired as is 3 is pretty secure. Write your service name. There is this one that I used. And then press create, and it will start creating Lambda, and that's it. I have one, so I'm not gonna press create. Once it's done, it will show up here as a private link Lambda, and yeah, the next step is to connect it. So once you have it, as you can see here, I see two of my apps that are backends are connected to it. But we'll show how to add it. So if you go to your dev space, I have in my sub account, I have a space called dev, and I have my backend there. So if you click on your backend there, you can say bind service, and you can pick up your user provided or from catalog here. There is another way which I'll show you later on. You can use the MTA file, and easier to add it over there. But it should show up here as private link. That is when you should be able to use it in your app. Coming to the next step, this is my app. But before I go, I'll just show you the MTA YAML. So here, if I go to MTA YAML, oh, sorry, it opened up here. Let me open up on this side. So if you see, the only thing you have to do is at the end of this file, by the way, I use BAS productivity tools, very good, very easy to use tool. I built a user input and a bot response chassis, only three strings input. Services, just click one time, it exposes them as services, and then I built a front end, which you will see it's very simple. It has just a user input and a bot response. So all this, you can do it in 5-10 minutes. That's pretty quick. Coming to MTA YAML, on the last portion of this, I added these 4 lines. So I am saying that there is a existing service, private link Lambda, and my service name is this. And this is in the resources, and on top of where your backend is. So in my case, this is my backend service. Let me find it here. This is my backend service name, and it's a Node.js. And in that, I need to have a require of private link. That's when it will show up over there. So these are the 2 things that you have to do, and then you can start using it. I showed you the code. That's exactly what you would do, and it will give you all the required answers that you need. Now let's run the app, the good part. So we have similar apps. So I'm going to start the SAP to AWS GenAI V2 Launchpad, which is here. This is the GenAI SAP to AWS GenAI V2. You click on this, it will open. Let me just click on it. It will open up my app. As I said, I have only 2 buttons here. So if I say go, I have a bunch of questions that I asked. Let's ask a new question. So let's go here and let's edit it. And we have insomnia. So this is the JSON that SAP is getting. So let's ask a question. Where does Regina Murphy work? So we'll just give a question. Where does and you send this. Now at this time, you go back to my presentation quickly to give you a context what is going on just that while it's running. It's pretty quick, but I'll give you. So it's going from here, UI5, CAP backend. It got the token. It's going to Lambda, coming back, getting the data from Northwind, giving it to LLM and answering. So this is what's going on right now. So we got, according to the data, Regina works at Grandma Kelly Homestead. So if you look at this, it is Grandma Kelly. Second thing you can say, let's go to another one. Let's say New England seafood. So we can ask, let me do it on the same one. What is the address of this one? So let's run it now. It is actually going to the JSON and reading and trying to figure out the address of New England and say that's the address, New England processing department. And this data is in Northwind. You can call Northwind and match it. It's the same. I actually filtered it in Germany and USA just to some values here. You can also call. So I'll ask a difficult question right now. So I'm going to say, list the companies from the USA. Now, this is not a simple question because it's not just the name, a value, a parameter, and then getting the response in the same JSON, you're getting the answer. This is list from all the JSON. So it actually went, saw the whole JSON, found out that these are the 4 companies out of these. There are some German ones in it. So Germany and Germany. So it is actually getting USA out of them. And there are 4. And it's answering. So just a simple context how you can call from SAP BTP Cloud Foundry to Lambda, and the Lambda is talking to SAP if you want, or you can go within BTP and get the data and give it to LLM to Lambda anyway. And then LLM is reading all that data and then answering you either from a live call from SAP where the data is changing, or stale data, a data that's not changing from Kendra. All that, and it merges them and gives you in a very nice way an answer. So this is the, one last thing I want to show is, this is how, if you haven't seen a Lambda, it's very simple. This is the Lambda we're calling from SAP. And it shows like this. You can actually have a test button here. You have the same event that's coming from there. You can actually put it here, press test, and it will give you an answer here similar to what's going back to SAP. So you can actually test both parts separately, SAP and AWS, and then join them at the end and have an answer very similar to this. So that's the end of it. Thank you so much. If you have any questions, please feel free to contact SAP, and we'll work together on it, hopefully. Thank you.
Thanks, Simon, Arne, and Farouk, for sharing your knowledge and expertise in this session. Also, thanks to you, the viewer, for joining the live event or the recording. There is plenty for everyone to learn during the Oktoberfest, so make sure to check out other sessions that are part of the event. Thank you. Bye.